Okay, so we're going to describe fully the single transformation that's represented by this matrix. Once again, there's a certain expectation that you should know a bunch of these walking into the exam, which would make these questions very quick and easy to do. Assuming that you don't know, and you need to work it out, then here's what we do. Whatever happens in this first column shows us what happens to the x vector 1, 0. Okay, so that's the x vector 1, 0. It's now become 0 minus 1, so it's ended up over here. The y vector 0, 1, what happens to that is represented by the next column. And that one's going to minus 1, 0, it's going over here. So this vector's ended up over here, and this one's ended up over here. We have to think of a single transformation that would do all of that all at once. Now it's clearly not a stretch or an enlargement or some kind of rotation, it must be a reflection, and the mirror line must be down in here. So that mirror line has the equation y equals minus x. So it's a reflection in the line y equals minus x, and that's how we do that. Again, if you've learned this off by heart, then there's no working out to do over here. You don't need to understand too much what's going on. You just write down the answer because you've learned it. Let's look at the next question. M is 2, 3, 2, 4, N is 2, 3, and P is 1, 5. Don't be fooled, this isn't a set of coordinates, this is a matrix with 1 row and 2 columns. I'm asked to find Mn. This is pretty straightforward, they're just testing to see if we can multiply together a matrix and a vector, which is a bare and a minimum, is definitely what you should be able to do walking into this exam. So for the first entry, that's 2, 3 times 2, 3, which is 4 plus 9 is 13. And then I've got 2, 4 times 2, 3, which is 4 plus 12 is 16. N times P, 2, 3 times 1, 5. This is quite an unusual one. Remember the domino rule for working out, first of all, if matrices will multiply together, and second of all, what the result will look like. This matrix has 2 rows and 1 column. It's a 2 by 1 matrix. The next matrix, the 1, 5 matrix, has 1 row and 2 columns. Matrices will multiply if the middle numbers match, and in this case they do. That's why it's a domino rule, they have to match. The resulting matrix will be whatever these outer numbers are. So believe it or not, we get a 2 by 2 matrix out of this multiplication. Let's see how that happens. The number in the first row, first column, is taken by looking at whatever the first row of this one is, and whatever the first column of this one is, and multiply them together. 2 times 1 is 2. For the first row, second column, I've got to do the 2 times the 5 to get a 10. Second row, first column, 3 times 1 is 3. And then second row, second column, 3 times 5 is 15. So that one's quite unusual and would have caused a lot of people out when this came up last year. M inverse. Remember the formula for the inverse that we discussed earlier on? For M, I've got to do AD minus BC on the bottom of a fraction. That's 2 times 4, which is 8, minus 2 times 3, which is 6. Then we have to jumble up the elements of M, swapping A and D, and giving the other numbers minus signs. So writing this in a slightly tidier way, that is 1/2 of 4 minus 3 minus 2, 2. Now for the next part of the question, we're asked to write down a product of 2 of the matrices, M, N, and P, which it is not possible to work out. So remember the domino rule. We can only multiply together 2 matrices if they follow the domino rule with their rows and columns. Now, here I have M, which is a 2 by 2 matrix, and if I try to multiply that one with, say, P, which is a 1 by 2 matrix, then these don't match, so it can't be done. So I cannot work out the product of M and P because they don't follow the domino rule. Now, in the next question, I'm asked to describe the single transformation represented by the matrix 3, 0, 0, 3. Remembering what we've talked about before, either memorize these or know how to work them out, your choice. We can see that the base vector for x, 1, 0, is now becoming 3, 0. It's becoming 3 times larger. That's a stretch in the x direction, scale factor 3. We could also see the same effect happening to the 0, 1, the y vector. That's also getting 3 times larger. So we're getting 3 times larger in both directions. That's an enlargement, scale factor 3. Now, enlargements need a center of enlargement, and whenever we're dealing with matrices, the center is always 0, 0. Now, if you are unsure about what I've done, another strategy here would be to maybe draw a little grid somewhere, put a couple of points and make a shape on that grid, apply that matrix to the coordinates of those points and see where it ended up and figure it out from there. That's obviously more time consuming, it's not the best way to do it, but it is a strategy to get you started on this question, if you're stuck. So the next question is just a very nice, can we work with matrices, can we multiply them, can we work out inverses? Not so much in the way of thinking about transformations, so it should be pretty straightforward. So I'm asked to work out n times m. Just note as well, the order of matrix multiplication does matter. If you write these matrices down in the wrong order, you will get the wrong answer, so make sure you're paying attention. They're given to me as m and then n in the question, but then the product is actually the other way around, so just be careful, read your questions carefully. Minus 3 times minus 2 is 6, and then add 1 times 5, that makes 11 in my first position. Minus 3 times 0 goes away, 1 times minus 6 is minus 6 in my second position. 0 times minus 2 is 0, and minus 1 times 5 is minus 5. Down here, and then finally 0 times 0 is 0, and minus 1 times minus 6 is 6. You want to be able to do this quickly and efficiently. The inverse matrix, once again, I'm just using that inverse matrix formula. 1 over AD, which is 12, minus BC, which is 0. I swap A and D, that's a minus 6 over here and a minus 2 down here. And I introduce minus signs in front of the other letters, the other elements. Minus 0 is still 0, and then I've got a minus 5. So that's the inverse matrix M, and I'd want to write this the tidiest way I could, 1/12, minus 6, 0, minus 5, minus 2. On to the next question. Another pretty straightforward question. We're asked to work out what A squared is and what A inverse is. So, A is 2 minus 3, 1, 4. A squared does not simply square all these numbers. Just like brackets, we have to remember that we have to multiply it by itself, and this is going to involve all these different steps. So I've got 2 times 2 is 4, add minus 3, which gets me 1. 2 times minus 3, minus 6. Minus 3 times 4, minus 12. So, minus 6 add minus 12 is minus 18. 1 times 2 is 2, add 1 times 4 is 4, that's getting me 6 altogether. 1 times minus 3 is minus 3, 4 times 4 is 16, so minus 3 and 16 makes 13. The inverse of A is what I get when I do AD on the bottom of this fraction, 8, minus BC, which essentially says plus 3. Swap A and D, so there's a 4 and a 2, and introduce minus signs in front of the other elements. minus minus 3 is of course plus 3. And I'll write this in a tidier way, 1 over 11, 4, 3, minus 1, 2. In part B, I'm asked to describe fully the single transformation represented by this matrix. What I see here is nothing happening to y, no change in y, because 0, 1 representing the y values is still 0, 1. But the x values are changing sign. This is a sign of a reflection. If my x values are going from positive to negative, that means they're being reflected in the y-axis. So nothing's happening to the y values. This is simply a reflection in the y-axis. Now I'm asked to find the matrix that represents a clockwise rotation 90 degrees around the origin. So you either know it or you have to work it out. My x10 vector, if I rotate that 90 degrees clockwise around the origin, it would end up down here, and that would end up at 0, minus 1. So the first part of my matrix, which represents what happens to 1, 0, that goes to 0, minus 1. My y values over here, my 0, 1 y values, if they're rotated, well, they end up being 1, 0s. And so what happens to the y values fills out the next column. That's 1, 0. So that's my matrix. I'll do the rest of the questions in the next video.